How many of you have a younger brother or sister? Okay, you might be thinking, why the heck am I asking this? Halloween is coming up, and let's say your brother or sister comes home with just big old pumpkin full of candy. Okay, you're going to take their candy. But you know how some people give like pencils and stickers and crackers for Halloween? Like you don't want that stuff, right? You just want the good stuff. So you're going to take their pumpkin, take the good stuff out, and then throw away the crappy stuff and give that back to your sibling, right? Okay, now how does this apply to what we're doing today? I'm going to give you an equation in this problem. The slope of this equation is the good stuff, and the y, the x, and the 7, that extra stuff, that's the crackers and the apples and the stickers and the pencils. Okay, you can keep the apple. Then 7 or 3 is the apple for you. Okay? So in this equation, y equals 3x plus 7. The good stuff is the 3. The rest of this is the crappy stuff that you don't want, and you throw it away. The reason I use this analogy is the most common error I see in this type of a problem is trying to put that 7 somewhere into the problem, and it doesn't need to be there. It's extra information that you don't need, so throw it away. We need to write an equation of the line passing through the point 1, -6 that is perpendicular to this line. And we already decided that this line has an original slope of 3. So what would be the perpendicular slope? What is perpendicular to a slope of 3? -1/3. Okay? First of all, do you remember that upside down capital T means perpendicular? And it's a whole lot easier than writing out the word perpendicular. Step 2, once we've identified the slope, is write an equation using the slope and the point given to you in the problem in point-slope form. So, point-slope form, we're going to do y minus a -6, which means it will be plus 6. Equals -1/3 times x minus 1. On your assignment today, it's going to ask you for the perpendicular slope. It's going to ask you for point-slope form. Then it's going to ask you for slope-intercept form. And then it's going to ask you for standard form. So it's just like what we did yesterday on the bullseye, but now we have to think about parallel or perpendicular first. So to get this in slope-intercept form, we would distribute the slope. So y plus 6 equals -1/3 x. And what is -1/3 times -1? Positive 1/3. Then we need to subtract 6. So y equals -1/3 x, and oh crap, we have to do 1/3 plus or minus 6. So using your fraction button, 1 fraction button 3 minus 6. Okay. And if it shows you a mixed number, then you change it back into an improper fraction. If you have a graphing calculator, here's a hint. You do parentheses, -1 divided by 3, close your parentheses, minus 6, and then if you punch your math button and say change to fraction, you can do that all in the same line, and it will do -1/3 minus 6 and then change it to a fraction all in the same step. Okay, it's on a graphing calculator. So this should be, what is it? Is it -17/3? Okay. At this point, the fractions are fine. So our slope-intercept form is y equals -1/3 x minus 17/3. Next, we need to get it into standard form. We would add 1/3 x to both sides. So we have 1/3 x plus y equals -17/3. But we cannot have fractions in standard form. How would we get rid of a fraction of 1/3? Multiply everything by 3. That will give us x plus 3y equals -17. Try example 9 on your own, and we'll see how you do. Okay, I'll start helping you out a little. The original slope in this equation is -3. That 2 in the equation doesn't matter. Cross the rest of that out. The only thing you care about is the -3. If the original slope is -3, what would be the perpendicular slope? Positive 1/3. All right. Point slope form. Y minus 2 equals 1/3 times x minus 3. Okay, I'll start showing my work over on the right. Slope-intercept form. We need to, my goodness, I just got a bunch of new emails. Distribute the 1/3. So we're distributing the 1/3. Would be 1/3 x minus 1. This one's a little bit nicer than the previous example. So y equals 1/3 x plus 1. You know, we'll just make random lines all over the place. It's not a big deal, program. Zoom out for no reason. And then standard form, we would subtract 1/3 x on both sides. So we'd have -1/3 x plus y equals 1. We can't have negatives in front of the x, so we definitely have to multiply everything by negative something. And to get rid of that 1/3, we multiply everything by -3. That will give us positive x minus 3y equals -3. So that would be standard form. Okay, I'm guessing after doing all of this work, we probably don't need to do number 10. The only thing I'd like to talk about with number 10 is, how is number 10 different from number 9? It says parallel. No, I don't want you either. What? All right, so if the original slope in this one is 5, what would be the parallel slope in this one? 5. So you would use a slope of 5 and the point 39 and do the exact same thing we did in number 8 and 9. Okay, we're actually going to skip example 12, so turn the page. One thing we should talk about to make sure this is clear for everyone. If you are asked for a parallel slope, parallel lines have the same slope. Perpendicular lines, do you see what we did in numbers 8 and 9? Perpendicular lines are opposite reciprocal slope. So take a look at number 9. The original slope was -3. The perpendicular slope is positive 1/3. So one of them's positive, one of them's negative, and they are flipped versions of each other. Reciprocal means to flip the fraction. So this original slope was -3. Put that over 1. You'd flip it to get 1/3, and then the perpendicular slope is positive because the original slope was negative. But if we're doing parallel, you use the exact same slope. So the slope is 5. you use the slope of 5, and you use the 0.39. So you would write y minus 9 equals 5 times x minus 3, and then you'd go to slope-intercept form, and then you'd go to standard form. Two variables, x and y, show direct variation. The direct variation equation is y equals kx. The key phrases that you're going to see are y varies directly with x, or the variable x and y vary directly. If you see that word varies directly, that means y equals kx. K is called the constant of variation. It's some constant number. Basically, it's the slope. It's y equals some rate of change times x. And what we're going to be doing in these problems is figuring out what that rate of change is. So in number 13, the variables x and y vary directly. That means we have this relationship, y equals kx. That's what varies directly means. Then they're telling us that y equals 12 when x is 4. So write an equation relating x and y. Done. Now let's plug in the known x and y values. So 12 equals k times 4. How could we figure out what k is? Division. You divide by 4 to figure out that k is 3. The next step says rewrite your equation of variation using x and y and your now known constant. Now we know that k is 3, so we are going to rewrite it y equals 3x. Basically, we figured out that the rate of change is 3. Next, find y when x equals 5. So now take this equation, y equals 3x, and plug in 5. What is 3 times 5? So y equals 15. So in your directions, it says write a direct variation equation. That would be this answer. Then find y when x equals 5. That would be this answer. I'd like you to try number 14 on your own.